Good evening to all. I am going to present on fire prevention and fire protection systems. Fire accidents can lead to severe loss of life, property, and environmental damage. Industries handling flammable materials are particularly vulnerable to fire hazards. Therefore, understanding fire prevention techniques and fire protection systems is essential for every engineer and worker. So in this presentation, we will discuss the fundamentals of fire, different types of fire protection systems, firefighting equipment, fire detection methods, and preventive strategies that help minimize fire-related risks. This presentation is divided into 6 major sessions. We begin with the fundamentals of fire, where we learn why fire occurs and how fires are classified. Next, we compare passive and active fire protection systems, which are the two major approaches used in buildings and industries. Then we discuss water supply systems, including hydrants, storage tanks, and riser systems. After that, we learn about automatic sprinklers and portable fire extinguishers, their working principles and proper selection. We also study special fire suppression systems including carbon dioxide, foam, halon, and Inergen systems. Finally, we conclude with fire detection and alarm systems, which play a crucial role in saving lives by providing early warning. What is fire? Fire is a rapid chemical reaction called combustion, which produces heat, light, smoke, and flames. For fire to occur, three essential elements must be present simultaneously. These are represented by the fire triangle. The first element is fuel, which can be any combustible material such as wood, paper, petrol, diesel, LPG, natural gas, or chemicals. The second element is heat, which provides sufficient energy to raise the fuel to its ignition temperature. Heat sources include sparks, electrical faults, welding operations, friction, or open flames. The third element is oxygen, which is normally supplied by the surrounding air. Oxygen supports the combustion process. If we remove any one of these three components, the fire cannot continue. For example, water removes heat, foam separates oxygen from fuel, and shutting off a gas valve removes fuel. Therefore, fire prevention mainly focuses on preventing these three elements from coming together. Different types of fires require different extinguishing methods. Class A fires involve ordinary combustible materials such as wood, paper, cloth, rubber, and plastics. Water is usually effective for these type of fires. Class B fires involves flammable liquids such as petrol, diesel, oils, paints, and solvents. Water should never be used because it spreads the burning liquid. So here we can use either foam or carbon dioxide extinguishers. Class C fires involve energized electrical equipment such as computers, transformers, electrical panels, and motors. Carbon dioxide or dry chemical powder extinguishers are used because they do not conduct electricity. Class D fires involve combustible metals like magnesium, sodium, potassium, and titanium. These require special dry powder extinguishing agents. Class K fires occurs in commercial kitchens involving cooking oils and fats. Wet chemical extinguishers are specifically designed for these fires. Correct identification of the fire class is essential because using the wrong extinguisher can make the fire much worse. So fire protection systems are broadly divided into passive and active systems. Passive fire protection consists of safety features that are permanently built into the structure. These systems do not require activation. For example, fire-resistant walls, fire-rated doors, fireproof floors, fire-resistant glass, and compartmentation. Their purpose is to contain the fire, prevent its spread, and provide safe evacuation routes. In contrast, active fire protection systems detect or extinguish fires after they occur. Examples include smoke detectors, heat detectors, sprinkler systems, fire alarms, fire extinguishers, and gas suppression systems. Passive systems buy valuable time during emergencies, while active systems directly fight the fire. Together, they provide comprehensive fire safety. Water is the most commonly used fire extinguishing agent because it has excellent cooling properties. Industries require a dedicated water supply exclusively for firefighting purposes. According to fire safety standards, hydrants should provide approximately 1000 liters per minute at a pressure of 3.5 kg per centimeter square. At least two hydrants should be capable of operating simultaneously during emergencies. Underground fire water storage tanks should provide sufficient water for at least 30 minutes of continuous firefighting. Tank covers should also be strong enough to withstand fire engine loads, typically around 18 tons. Proper water storage ensures firefighters have an uninterrupted water supply during emergencies. Firefighting systems are divided into external and internal systems. External systems include city water mains, pillar hydrants, flush hydrants, and underground pipelines. Hydrants are usually installed 90 to 120 meters apart in populated areas to ensure adequate coverage. Internal systems protect buildings from within. These include wet risers, which are always filled with water and ready for immediate use. Dry riser remain empty until firefighters pump water into them during emergencies. Buildings also contains hose reels, sprinkler systems, portable extinguishers, and alarm systems. So together, these systems enable rapid firefighting inside the building before the fire spreads. Residential buildings and industrial facilities require different levels of fire protection. Residential buildings generally use hose reels, portable extinguishers, sprinkler systems, and fire alarms. Industrial facilities, especially chemical plants, handle flammable liquids and hazardous materials. Therefore, they require more advanced protection systems. These include high velocity water spray systems, foam suppression systems, dry chemical powder systems, carbon dioxide flooding systems, and automatic alarm systems. Industrial fire protection is designed to quickly control fires involving chemicals, fuels, and process equipment while minimizing production losses. How an automatic sprinkler works. Automatic sprinklers are one of the most effective fire suppression systems. When a fire starts, hot gases rise toward the ceiling. The heat reaches the sprinkler head. Inside the sprinkler head is either a fusible metal link or a glass bulb containing a heat sensitive liquid. So when the temperature reaches a predetermined value, the fusible link melts or glass bulb breaks. This opens the sprinkler head and releases pressurized water directly onto the fire. Contrary to the popular belief, Only the sprinkler nearest the fire activates, not all the sprinklers simultaneously. This controls the fire quickly while minimizing water damage. So sprinklers are classified based on how they distribute water. Conventional sprinklers, umbrella and sidewall sprinklers. So conventional sprinklers spray water both upward and downward, providing uniform protection. Whereas umbrella sprinklers mainly direct water downward in a parabolic pattern and are commonly installed on ceilings. Sidewall sprinklers are mounted on walls and distribute water outward in one direction. The selection of sprinkler type depends on the building layout, ceiling design, occupancy, and fire risk. Proper sprinkler selection ensures effective fire suppression with minimum water consumption. So now let us discuss about the fire extinguisher. Portable fire extinguishers provide the first line of defense during the early stages of a fire. The main parts include the cylinder, pressure gauge, discharge hose, nozzle, carrying handle and operating lever. To operate an extinguisher safely, remember the PASS technique. PASS technique. P stands for pull the safety pin. A stands for aim the nozzle at the base of the fire. S stands for squeeze the operating lever. The final S stands for sweep the nozzle from side to side until the fire is completely extinguished. Always keep a safe exit behind you while operating a fire extinguisher. So different extinguishers are suitable for different fire classes. So water extinguishers are used only for class A fires because they cool the burning material. Carbon dioxide extinguishers are ideal for class B and class C fires, especially electrical equipment, because carbon dioxide displaces oxygen and leaves no residue. Dry chemical powder extinguishers interrupt the chemical chain reaction and are effective on Class B and Class C fires. Foam extinguishers create a blanket over flammable liquids, preventing oxygen from reaching the fuel, making them suitable for Class A and B fires. Selecting the correct extinguisher is essential for safe and effective firefighting. Gaseous suppression. Certain areas cannot be protected using water because water damages sensitive equipment. In such locations, gaseous suppression systems are used. Halon systems were widely used for electrical rooms, computer centers, and aircraft because they extinguish fire rapidly without leaving residue. However, halon damages the ozone layer and is now banned in many countries. Modern systems use Inergen, which contains 52% nitrogen, 40% argon, and 8% carbon dioxide. Inergen lowers the oxygen concentration enough to extinguish fire while remaining safe for people in occupied spaces. So these systems are widely used in data centers, museums, archives, and electrical control rooms. Early fire detection is critical because the first few minutes determine whether a fire can be controlled. Fire detection systems include smoke detectors, heat detectors, and flame detectors. When a detector senses a fire, it sends a signal to the fire alarm control panel. The alarm immediately warns occupants to evacuate safely. At the same time, the system may automatically activate sprinklers or notify the local fire department. Some modern facilities use hypoxic air systems which continuously reduce oxygen concentration to prevent ignition from occurring in the first place. Early detection significantly reduces casualties and property damage. So let us summarize the important points. Fire occurs only when heat, fuel and oxygen are present together. Understanding fire classifications help us choose the correct extinguishing agent. Passive fire protection slows the spread of fire, while active system detect and suppresses fire. Adequate water supply, hydrant, sprinklers and extinguishers are essential for industrial safety. Early fire detection and alarm systems provide valuable time for evacuation and emergency response. Regular inspection, maintenance, employee training and fire drills ensure that all fire protection systems function effectively when needed. Thank you all for your attention. Fire safety is not only about responding to emergencies, but also about preventing fires before they occur. By understanding fire behavior, selecting the correct protection systems, and following proper safety practices, we can significantly reduce the risk of fire accidents in industries and public buildings. Thank you once again.